Hi everyone, today I am going to discuss some very important questions of operating system. Let's begin. The first question, wait, okay. The first question is, which of the following is not a type of operating system? Real-time operating system, time-sharing operating system, batch operating system, gaming operating system. This is very simple question. It is game operating system. Okay. Next one, which type of operating system is designed to provide a secure environment for user processes? Distributed operating system, time sharing operating system, secure operating system, network operating system. Secure environment means secure operating system. Okay. Next one. Which of the following is well-known open source operating system? Very again a simple question. That is Linux. The Linux is open source operating system that is well known. What is the purpose of copying the contents of an operating system from a storage device to the main memory referred to as? That is known as booting. Okay. Next question. What is the name of the program that acts as the interface between the user and the operating system? The correct answer is shell. What is the purpose of a device driver in an operating system? Device driver to provide a user-friendly interface, to manage and control hardware devices, to provide security for the system, to execute user program. The correct answer is to manage and control hardware devices. That is the purpose of device driver. Manage and control hardware devices. Next question. Which of the following state transition is not possible? Block to running, ready to running, block to ready, running to blocked, which is not possible. This case, that is block to running, that is not possible. The process from blocked to waiting state is sent to ready state, and not from there it can be sent into the running state. Okay, it will never send to running state, it will only send to the ready state. Which process can affect or affected by other processes executing in the system? That is cooperating process. Cooperating because cooperating process may show data with each other. Means that may share data with each other, so it can be affect or affected by other processes executing. Scheduling is done so as to, it is mainly done to increase CPU utilization. Increase CPU utilization. Okay. Which state of process define the process is being created? The starting of the process. When it is created, it will be new state. That's all a very simple question. Basic things. Okay. Next one. The degree of multi-programming is controlled by CPU scheduler, long-term scheduler, context switching, medium-term scheduler. That is long-term scheduler. Which of the following scheduling algorithm could result in starvation? That is starvation, priority, round robin, first come, first serve, none. The correct answer is priority. That could result in starvation. Next one, the Candice scheduling algorithm is also called, that is also called elevator. Elevator algorithm. It's not circular scan or not circular look or first come first serve. It is elevator. Candice scheduler algorithm is also called elevator algorithm. Okay, what is dispatch latency? What do you mean by dispatch latency? The time taken by the dispatcher to stop one process and start another, or the time taken by the processor to write a file into disk, or the whole time taken by all processor, or none. Which will be the correct answer? The correct option is A. That is the time taken by dispatcher to stop one process and start another. Okay. Next one, what is the SOMPI process in process management? A process that has complete execution but its resources are still being held by the operating system, or a process that has been scheduled but not yet executed, or a process that is blocked and cannot be executed, or a process that has terminated but its resources are still being held by the operating system. By looking this all the option, you may be getting confused, but the correct answer is a process that has completed execution but its resources are still being held by the operating system. Okay. And what is a deadlock in process management? That means a situation where two or more processes are blocked and cannot continue execution, or situation where two or more processes are executing simultaneously, or a situation where two or more processes have the same priority, a situation where two or more processes have the same memory usage. And the correct answer is a situation where two or more processes are blocked and cannot continue execution. They are blocked and they cannot continue the execution. That means one want to share others resource and other one also want to share, and they are both two or more processor, they are blocked and cannot continue execution. What is priority scheduling in process management? A method of scheduling process based on priority level, or based on randomly, or based on memory usage, or based on CPU usage. The correct answer is a method of scheduling process based on priority level. Common question. What is a race condition in the process management? This is very important question. Just look on this. A situation where two or more processors access the same resource simultaneously. A situation where two or more processors compete for the same resource. Or a situation where two or more processors block each other. Or a situation where two or more processors are depend on each other. And the correct answer is option number B. That is a situation where two or more processors compete for the same resource. They both want the same resource and they both are competing for each other. That is known as race. Next one. What is the main goal of a process scheduling algorithm in an operating system? To allocate CPU time to multiple processors, to manage memory allocation, to manage I/O operation, or to manage processor execution. The correct answer is to allocate CPU time to multiple processors. Which of the following is a non-primitive scheduling algorithm? Round robin, first come first serve, shortest job first, or priority scheduling? Non-primitive means that is first come first serve. Yeah, first come first serve. That is non-primitive. Rest all are primitive. Which of the following scheduling algorithm ensures that the process with the shortest execution time is executed first? Round robin, first come first serve, shortest job first, or priority scheduling? Shortest execution time is executed first. That is shortest job first. What is the primary disadvantages of the priority scheduling algorithm? It can lead to starvation of low priority processes. It can lead to higher response time for interactive applications. It can lead to high overhead for the context switching. It can lead to low CPU utilization. The correct answer is it can lead to starvation of low priority processes. Starvation of low priority processes. Which of the following synchronization methods require the use of semaphore? That is monitors or message passing, lock-based synchronization, conditional variable. That is lock-based synchronization that require the use of semaphore. What is the primary advantages of using monitors over semaphore for process synchronization? Monitor provide a higher level of abstraction, or monitor are more efficient than semaphore. Monitor are easier to implement than semaphore. Monitor are more flexible than semaphore. Maybe getting confused, but the correct option is monitors provide a higher level of abstraction. It provide a higher level of abstraction. Which of the following synchronization method uses buffer to store message between processor? Is it monitors, message passing, lock-based synchronization, conditional variables? The correct answer is message passing. Used to store message between processor. Okay. The interval from the time of submission of a process to the time of completion is termed as waiting time, turnaround time, response time, throughput. The correct option is turnaround time. Turnaround time means completion time minus arrival time. Mathematical question may be getting from this type of like turnaround time, wait time, waiting time, turnaround time, response time, throughput. Depending upon all this, you may receive some questions, mathematical questions. Round robin scheduling algorithm fall under which category? Round robin, preemptive scheduling, non-preemptive scheduling, sometime preemptive and sometime non-preemptive, or deadlock detection. Basically, it is preemptive scheduling. But that means a process has been given, the CPU can take away. Once a process has been given, the CPU itself can take it away. That strategy of allowing processes that are logically runnable to be temporarily suspended is called a preemptive scheduling. That means CPU can take it anyway, anytime. That's what is known as preemptive scheduling. So round robin fall under preemptive scheduling. Which of the following process scheduling algorithm may lead to starvation? Starvation. FIFO, first in first out, round robin, shortest job first, none of the above. The correct option is shortest job first. That may lead to starvation. Mm. That means it take long time to complete. If it is short process also, it will take very long time to complete. Okay, one numeric is there. Okay, for job are to be executed. So you can write here process and arrival time. Okay, this is which one is given? Round robin scheduling. You want to do in round robin scheduling. This is your arrival time, and next one is your burst time. Okay, and in what in round robin with a time slice of 1. What the time slice is given, that is 1. Okay, that is very important thing in this round robin. And which are the processes given? A, B, C, D. And arrival time will be 040 A, 04B, and 04C, and 04D. Okay, and what is the burst time for first one? 4, 1, 8, 1. Okay, this is one given. Give me a second. Let me change color. Okay, and what is the time quantum? Time quantum is given as 1. So here it always execute the job. In how the round robin will work, it will always execute the work in first come first serve. That is the process of doing, and working is always depending upon time slice, and the time quantum here is 1. Okay, let us look. Where is the okay. So first, which process? It will be starting from A. First, it will be always based on first come first serve. So first process is which one? A, no. So right here A, and it will be begin from 0. And what is the time quantum given? That is 1. Okay. So here it will become 3. Next one, it will be move on to the next one. That is B. B again, it will be taking 1. That means it will become 2 here. And here the time it will become 0. And next it will be move on to C, and the C is time quantum again 1. So it will be working 3, but here it will become 7. Okay, and the next process will be move on to the next D, and D again you want to give 1 time slice, so it will become 4, and this will become 0. So see, you can see here B and D, that process is completed. Next, no need to think about B and D. Next, we want to only check process A and D. Again, A will be coming. A, five. Next one, C. C, it will be 6. Next again, A, that will be 7. Next again it will be move on to C. It will be completing 8. Next again A, that is 9. So A completed. A has completed its job. Its process is completed. Next only C. So remaining will be 14. But you should be very careful here. What the question is asked is, for job to be executed on a single processor system, arrive at a time 0 in order to ABC the burst CPU time required 418 time. The completion time of under round with time slice of 1 unit time is, wait, let me highlight. Okay. Completion time of process A. So what is the completion time of process A? The completion time of A, sorry, let me write, this is capital letter A. That means here it is asked about the process of A. What is the completion time of process A? See, A is completed at which time? It completed at 9. So the correct completion time of process A is 9. So the correct answer is 9. Okay. Hope everyone understood. Next one, semaphore are used to solve the problem of deadlock, mutual exclusion, messaging, none. All in this, all questions or some of the questions are repeatedly asked in your KVS. So it's very important question, mutual exclusion. Semaphore is used to solve the problem of critical section. And the critical section means it problem depend upon 3 cases. Which are the 3 cases? Mutual exclusion, bounded waiting and progress. Okay. So semaphore used to solve the problems of mutual exclusion. Next one. In counting semaphore, when process is selected for the entry into critical section, it is shifted from dash state to dash state. It is shifted from blocked to ready, ready to blocked, waiting, running, running and waiting. Which state to which state? It is blocked to ready state. Okay. The Banker's algorithm is used to, important question, maybe getting confused because everything seems to be similar. That's why you will be getting confused in this one. To rectify deadlock, to detect deadlock, to avoid deadlock, to solve deadlock. The correct answer is to avoid deadlock. Banker's algorithm is used to avoid algorithm. If a process is in unsafe state, then it is in deadlock. It might successfully complete. It will lead to deadlock, none of the above. Maybe getting confused in this, but seeing the question itself, the answer you can find out. It might successfully complete. Because a process in unsafe doesn't always lead to deadlock. The process in unsafe may get successfully completed. Okay. The dash is a memory management scheme that removes the requirement of continuous allocation of physical memory. Compaction, resident monitor, paging, scheduling. Direct question, paging. Okay. Non-continuous memory allocation splits program into blocks of memory called dash that can be loaded in non-adjacent hall in main memory. Pages, frame, partition, segments. Which one? Yeah, segments. Which of the following problem is faced by first fit, best fit and worst fit algorithm? Internal fragmentation, external fragmentation or both or none? That is both internal and external fragmentation. Which memory management scheme avoid external fragmentation? Segmentation, paging, continuous memory allocation, or nothing? Which one? Paging. That is a memory management scheme which avoid external fragmentation. Copying a process from memory to disk to allow space for other process is termed as. See, it's a method for copying. Yeah, swapping. Swapping. That swapping, it is a method of for copying a process from the main memory to the disk and also the disk to the main memory. Both process it will be happening to allow space for the other process. It will allow the process for the allow space for the other process. So it's swapping. Vice versa also copying a process from memory to disk and also disk to memory. That is swapping. Okay. In which of the following operating system structure various services of OS run in user space? Microkernel, layered structure, symbol structure, none. Yeah, that is microkernel. Microkernel means in microkernel structure, non-essential components are removed from kernel to make it smaller, that it will make into micro and are implemented then as the system and user level program. Okay, that means non-essential components are removed from kernel. In which of the following operating system various service operating run in user space? That is microkernel. It's not layered structure and symbol structure, it is microkernel. Multi-level feedback queue scheduling allows a process to move between stack, register, memory or queue. That is, yeah, queue. That's simple question. Queue. Which one of the following is the visual way to determine the deadlock occurrence? Visual way of that is resource allocation graph or starvation graph, inversion graph, recursion graph. Which one? It is a resource allocation graph. That is a visual way to determine deadlock, mathematical way of determining. Which of the following is not a method to deal with problem of deadlock? Deadlock prevention protocol, detection, occurrence process or recovery process. That is deadlock occurrence process. That is not a method to problem deadlock. If a process is in safe state, then here it's written it. Okay, it will never go to deadlock. It might lead to starvation. It will definitely lead to deadlock and none. So if a process is in safe statement, it's obviously it will never go to deadlock. It will never go to deadlock. The technique used to store program larger than memory is overlays, extension register, buffers or none. That is overlays. That is the technique used to store the program larger than memory, virtual memory. That concept is coming. Effective access time is directly proportion to a page fault rate, hit ratio, memory access time, none of the mention. Effective access time is directly proportion to page fault rate. Okay. Oh, again numerical. Calculate the size of a memory if it is address consisting of 22 bits and the memory is 2-bit addressable. So number of location with the 22 bit. How much is the location? That is you have 22 bit, so it will be 22 bits means it is 2 raised to 2 raised to 22. 2 raised to 22 location. Okay. 2 raised to 22 location. And what is the given size of one location? What is the memory is 2-byte addressable. So size of one location is it's 2-byte. So size of memory will be equal to 2 raised to 22 into 2. That is a 2-byte addressable now. So 2. So here 2 means you can write 2 raised to 1. So the answer will be 2 raised to 22 plus 1 because it's multiplication and you will be adding. So 2 raised to 23. 2 raised to 23 means it is 8 MP. Okay, 8 MB. Directly answer is not given. So you want to understand the question and read it properly. Find the solution. Calculate the number of bits required in addresses for a memory having the size of 16 GB assuming the memory of 4-byte addressable. Okay. Here, and number of bits are required, no? So let n be the number of bits required. Then the size of memory. How will you find the size of memory? The size of memory. The size of memory is equal to 2 raised to n into 4 byte, no? Yeah. The given memory has how many GB? It's given here, it is 16 GB. So 2 raised to n into 4 byte is equal to how many is given? 16 GB. And everything you can write in term of 2. Then only you will be able to solve. No, that's why. And 4 you can write it as 2 raised to 2 is equal to, and 16 how can you write? 2 raised to 4. Yeah, but one problem is there. Here it is given 16 GB, no? Yeah, 16 GB. So it is not 4, it is 2 raised to 34. Yeah. So it will be 2 raised to 34. Now your direct equation 2 raised to n, how can you find out? You can take it into the other side. So it will be 2 raised to 34 divided by 2 raised to 2 and same power. So division means you want to subtract. No, 2 raised to 34 minus 2, which is equal to 2 raised to 32. So what is given? 2 raised to n is equal to 2 raised to 32. Therefore, what is the value of n? N is equal to 32 bits. So the correct option is, 32 bits. Understand? Okay. Which of the following is the simplest? Which of the following is the simplest page replacement algorithm? That is FIFO. First in, first out. The aim of creating page replacement algorithm is to replace page faster or increase the page fault rate, decrease the page fault rate, or to allocate multiple pages to processor. The correct answer is decrease the page fault rate. Decrease the page fault rate. Okay. Now the last question. In Peterson's solution for the critical section problem, which of the following is true? Mutual exclusion is preserved, the progress requirement satisfied, the bound waiting requirement is met, all of the above. Yeah, Peter solution means all of the above, because all the cases are satisfied. That's why solution, Peterson solution for the critical section problem, mutual exclusion is preserved, process requirement satisfied, and bound waiting requirement is met. So the correct option is all of the above. Hope everyone understand this video, and you watch this video 1 or 2 times and understand this question. Every questions are important, and in operating system you can score the complete mark in this topic, because I have covered more. That means I have covered the very important questions for you, and this is very important. Have a look at one more time and you will understand it more clearly. Okay, thank you. And if you like this video, please subscribe and support me. Thank you.